In this video, we will talk about the binomial theorem, namely a plus b the whole power n is equal to sigma k is equal to 0 to n nck into a power n minus k into b power k, where a and b are two terms. They are called binomial terms. So we will talk more in detail in this video about this binomial theorem. As part of the binomial theorem, now let us consider a plus b is a binomial. The two terms are a and b. Let us multiply a plus b by itself using polynomial multiplication. That means a plus b into a plus b is equal to a square plus 2ab plus b square. Now take that result and multiply it again by a plus b, then you get a square plus 2ab plus b square into a plus b, that is equal to a cube plus 3a square b plus 3ab square plus b cube. Again, if you multiply this factor by a plus b, you get a cube plus 3a square b plus 3ab square plus b cube into a plus b is equal to a power 4 plus 4 a cube b plus 6 a square b square plus 4ab cube plus b power 4. Now you are getting a kind of pattern. Let us continue further. We will now use the simple binomial a plus b, but it could be any binomial. Let us start with the power 0, that is exponent of 0, and build upwards. Exponent of 0. When you apply, what is happening? When the exponent of 0, we get a plus b power 0 is equal to 1. Just following the principle that anything power 0 is 1. Now let us talk about the exponent of 1, that is, we are considering the power 1. When you consider the exponent of 1, a plus b power 1 is nothing but a plus b. When you consider the exponent of 2 and how to multiply the polynomials, here you get a plus b power 2 is equal to a plus b into a plus b, that is nothing but a square plus 2ab plus b square. Next, let us consider the exponent of 3, that is power 3 we are using. That means a plus b power 3 is equal to a square plus 2ab plus b square into a plus b, that is nothing but a cube plus 3a square b plus 3ab square plus b cube. So, if you study the pattern now, what is happening? A cube plus 3a square b plus 3ab square plus b cube. Now notice that the exponents of a, it is just going down 3, 2, 1, 0. At the same time, the exponents of the second term b is going upwards, that is 0, 1, 2, 3. So you are getting, when you consider the exponent of a, in the first term you are getting a cube, in the second term you are getting a square, the third term you are getting a, and the last term you get a power 0, that is nothing but 1. So the power of a is decreasing. At the same time, the power of b is increasing. The first term you are getting b power 0, the second term b power 1, and the third term b power 2, the last term b power 3. That is fourth term you are getting b3. Now let us further study for our convenience. We will be using certain notations. The NCK, that is nothing but choosing number of that is k items out of a set of n items, that is called NCK, that is equal to n factorial divided by k factorial into n minus k factorial. Here factorial means, for example, you consider 4 factorial is equal to 4 into 3 into 2 into 1, that is equal to 24. Similarly, n factorial, when you consider, that is nothing but n into n minus 1 into n minus 2 into etc. 2 into 1. So this we will be using, this notation we will be using in binomial theorem. So the calculation now get longer and longer as we go, and there is some kind of pattern developing. That pattern is summed up by the binomial theorem, namely a plus b whole power n is equal to sigma k is equal to 0 to n into nck a power n minus k into b power k. Here, if you look at this pattern, when k is equal to 0, you apply. When k is equal to 1, you apply. Like that, when k is equal to n, you apply. You will get the similar to the examples. A plus b whole square is equal to a square plus 2ab plus b square. And a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Like that pattern for n terms, we are in the abbreviated form, we are expanding like this. This theorem is known as the binomial theorem. Hope you like my lecture on this binomial theorem. I am Dr. Sridhar, the former Vice Chancellor of Dr. K.N. Modi University and also Professor of Computer Science. If you like, please watch this video, look for more videos by subscribing to my channel. Thank you very much.